Yeah, let's start off. So we have a proton and an alpha particle projected into a uniform magnetic field with same velocity, same kinetic energy, same potential difference, same electric field for same time. Find the ratio of radius and the time period. There are four questions there. Hope you guys remember the formulas for radius mv by qb. Time period is 2 pi m by qb. Let's see. So first thing, right? The time period, if you look at this, time period t is 2 pi m by qb. So time period is proportional to mass by q. So time period of proton by time period of alpha, that proton ka mass is 1 by 1, alpha ka mass is 4 by 2. So this is a, this is same for all. So it doesn't matter what case it is, whatever you do, this is the time period. So time period does not change with the velocity or anything. It depends only on mass and q. Now, if you give same velocity, we know the formula r is equal to mv by qb. So since velocity is same, r is proportional to m by q. So the same ratio, answer is 1:2. If you give same kinetic energy, then you can write mv momentum as root over 2m into kinetic energy by qb. So radius is proportional to root m by q. You can solve that. I will leave it to you. What is potential difference? Potential difference when you give it, so kinetic energy is charged into potential difference. So this is root over 2 into mass kinetic energy by qb. This becomes a root 2m kinetic energy is charged into voltage by qb. So this guy becomes proportional to root over m by q. If you give same electric field for same time, then we know eq into time, that's basically force into time, is equal to change in momentum, which is m into v. So we get radius is equal to mv by qb. So mv is eqt by qb. Q and q will cancel. This is constant. 1:1. Check. So if you know this proportionalities, you are done. You can substitute the values and finish it off. Mass of the proton is 1, alpha is 4, charge of proton is 1, alpha is 2. Clear with this? In this, if you ask me, C and D are the pretty good ones. Those are the kind of questions you will get. The same velocity, same kinetic energy, it's fine. Matlab, they asked multiple times, but same electric field for same time and same potential difference are good. Clear with this? I could have asked you one more, same electric field for same distance. That would be the same as the same potential difference because field into distance is potential difference only. Right? So that case would have been the same. Let's get these two. A particle enters a magnetic field region at an angle alpha and leaves with beta. Find the relation between alpha and beta. This is a direct result actually. Exam may you can derive, it will take little time. Second thing, a particle is projected with speed u. You know what is the cycloid. You don't need that for means. Advanced may they might ask you the trajectory and all that stuff. But the question is simple. There is an electric field, there is a magnetic field. Find the speed of the particle when it reaches x, y. That's a pretty good question though. Both are pretty good. A part, right? Most people know what to do when it enters perpendicular and leaves like this. The moment I give you an angle, if you actually go back to the notes and check, right? We even did when you had multiple layers. What was the result? Matlab, if you try to derive exam, you're gone. So the result here is sine beta minus sine alpha is d by r. That was the result. In case you want to derive, so this is what we do: drop a perpendicular from here and drop a perpendicular from here. So that would be the center. And then we will say let this distance be x. Then we drop a line here. So then we get it. So this is alpha, this is beta. From there we can calculate. So that is sine beta will be x plus d by r and sine alpha will be x by r. Where that green line is the radius and this thing. So yeah, not a difficult derivation, but you can get it. That is the relation between this. If alpha is 0, then you get your regular formula. Sine beta is d by r. Again, be careful. This is valid when that beta is less than 90 degrees. Clear with that? What about the B part? If you're going this, if you remember, the path is actually a cycloid. What is the speed of the particle when it reaches x, y? There's an electric field, there's a magnetic field, charged particle is q and m. Gravity is not there. Work done by all forces is change in kinetic energy. There are only two forces, electric field and magnetic field. Magnetic field will not do any work. So therefore, work done by electric plus work done by magnetic is equal to change in kinetic energy. Work done by magnetic is always zero. Since electric force is always constant, EQ, you only need the vertical direction y. That is equal to change in kinetic energy. So half m v square minus half m u square. बस हो गया एक step में. If they ask you to find the coordinates as function of time t, that would be a deadly advanced question. That would be an advanced paragraph. But if I just ask you speed, it's a pretty decent question. Clear with this. So only the electric field will do work, the magnetic field will not do any work. So you're done. That's straightforward. Same question, you could have done something like this. What if the magnetic field here, V, is not constant? B is equal to B naught into 1 plus x by d. X is equal to 0, X is equal to D. We'll keep it simple. Let's say it is entering at an angle alpha. Can you find beta then? Now, can you find the relation between alpha and beta? You can't use that formula now. This is a variable magnetic field. This would go actually beyond mains. You need to know that the variable thing. See, think of like this. If you divide this into multiple layers, let this distance be d1, let this distance be d2, d3, b1, b2, and so on. So when you're entering, right, if this angle is alpha, let's say when you enter here, it is theta 1, because the dx is small. So you enter with alpha 1. When you enter here, this is theta 1. So when you enter here, this is theta 2. When you enter here, it is theta 3. Basically, the initial angle, final angle will be the initial angle for the next section. So this is how the formula would propagate. Say sine theta 1 minus sine alpha will be d1 by r1 sine theta 2 minus sine theta 1 for the next section. Theta 1 would be the entry angle, d2 by r2, and so on. If you do this, you'll get a telescopic function, sine beta minus that sine theta n minus and whatever will be dn by rn. So when you add all of this, you end up with sine beta minus sine alpha is sigma di by ri. Clear with this? This is the case when you have thin sections. Now, if you take dx sections, then your formula will become sine beta minus sine alpha. Sigma becomes integral. The d becomes the thickness. So here you will take such a small thickness, dx. So dx will become, d will become dx, and the radius will become mv by q b, magnetic field at that x. Limits will go from 0 to d. So this will be q by mv integral b naught 1 plus x by d dx. Limits will go from 0 to d. That would be d plus d square by 2d. That will be 3. So 3 qb naught d by 2mu. Clear with this? So that sigma becomes integral there. Check it out. So basically that telescopic function, right? That sigma summation here, that you should know that thing. Yeah. I'm not sure, and you can check it out and see. Clear with this? Let's get this thing. If you think you can do that, do it, get the answer, and then let's discuss. If you're not getting an answer, what you're doing is something wrong. So let's not do research now. This thing is another standard question. Mass m, mass q, speed u, theta. Mass m minus q, speed u, theta. Draw the path and time spent inside the magnetic field. I hope you know the direction of the magnetic force QB cross B. Hope you guys attended that moderator session. Not sure how much useful it is, but yeah. Someone was conducting it, we hijacked it. If they conduct for other subjects, I'll send it. And unfortunately, there's nothing for CBSE. So, yep. If I'm checking out, if there is someone doing for CBSE, we will do that also. We'll hijack them. But I don't think anyone will do actually. Keep your cams on, everyone. What is the answer for this? Shouldn't take much time for this. This is an easy one. So QV cross B. So for this guy, the force will be actually outside. This is the center. So this will enter like this and will come out like this. So if this is theta, theta, this is 90 minus 90 minus theta, this is 2 theta. So the time spent inside will be theta by 2 pi into time, capital T, where T is 2 pi m by QB. For this guy, QB cross B, the force is toward the center. This is the center. Hope you know how to guys do this thing. V cross B cross product. So this thing is going in a bigger circle and comes out like this. This angle is 2 theta. That means you are inside for 2 pi minus 2 theta. So your time spent is 2 pi minus 2 theta by 2 pi. Unitary method basically. For 2 pi, you're taking capital time T. For this thing, how much time will you take? Clear with this? Standard stuff, you should know. Get this thing. Particle projected with speed v, it is in the xy plane. So basically v cos theta I cap, v sin theta j cap. Magnetic field is bi cap. Find the pitch and the radius of the helix and find coordinates of the time t. ये काम करते wait. We'll put electric field also. Then pitch will not be able to find actually. ठीक है छोड़ दो. Pitch will keep changing. You know this thing, you know how to do helixes. So bar magnets and all, we're going to do it later. So in this, we are doing force and current right now. Bar magnets is still important. Even at an advanced level, they can still, add up those magnets in the questions. So bar magnets may you have that vibrational magnetometer, moving coil galvanometer ka construction, right? Those two are there. What else is there? The magnetic field due to a magnet when the length and radius length of the magnet is comparable. So they're like magnetostatics basically. So there are 3-4 main concepts. Get this. So what are you guys all planning for New Year? Eating, sleeping. You guys can take a break day off actually for one day. Nothing happens. You should not be always like a pressure cooker situation. There's no point in, putting so much stress. Your performance will actually decrease. Like now, last 10-15 days, try to little, calm down a bit. It is better you spend 1 hour on yourself, right? Spending time with you, going for a walk without music. That actually helps a lot if you can do that every day. I told you this before also. Go for a walk every day for 1 hour, maybe evening or something, after all studies are done. No music, nothing. Just be with yourself and just go for a walk for 1 hour. Trust me, it helps you a lot. For the first 10-15 minutes, you will get frustrated and all. Next 15-20 minutes, all the thoughts will come and pass by. Next 15 minutes, you'll start feeling calm. Last 10 minutes, you'll be enlightened. Meaning legs will start paining by then. So you'll come back home. It helps a lot. You can do that. It will sort things, a lot of things. The biggest problem, we humans face, right? We don't talk to ourselves. When you have a problem, bloody, we talk to everyone except ourselves. So whoever is feeling, right, there is a trauma, it's too much stress and all. Serious, I'm telling you, do that. Do that for a week. Go for a walk every day. Maybe not 1 hour, go for 40 minutes. Without music, nothing, no distraction. You are just with yourself. Should definitely do that. Helps a lot. You being calm is more important than studying that extra 1 hour. What is the point? You go to the exam and you blank out. Seriously, when I wrote my IEEE exam, what saved me is my self-talk only. I was in a complete panic mode. I don't know why. Told you, right? When I wrote my IEEE exam. IEEE 2006. That was my second attempt. Right? Went to the exam. During that time, the exam, I think it was 55 questions or 60 questions per subject. I think 60. PCM. That's 180 questions, 3 hours. 60, 60, 60. It's like your speed test. Right? Little simpler version though. So 180 questions, 3 hours. So this was the JEE mains that time. So this is the exam which through, you go to NITs and all. So I went to the exam. When I always start with chemistry. My order is always this. I start with chemistry, then I do maths, I do physics last. Because physics is my like savior. I know, like, even in the end, even if I panic, even in that panic, I'll do my physics well. So that is a kind of confidence you should have on your subject. Like there is always one savior. Maths is one subject when I am completely fine, also I'll mess up and come. Wo bhi confidence hai. Getting it? So I was always a contradiction. Like, I always had two kinds of confidences. You give me any question in physics, I will do. You'll give me any question in maths, I'm sure I won't do. That's a bad type of confidence, but that's what costed me in 2005. That was very bad. But yeah, I improved a lot on that. Max, I really didn't love Max, but I didn't hate also. I understood in Max, I loved certain things. I didn't love certain things. I loved probability, right? I loved circles. I loved straight lines. I loved parabola. I hated ellipses and hyperbola for some reason. I liked straight lines. I hated matrices. I liked quadratic. So probability and permutation combinations was my favorite. So there were certain things like calculus with differentiation. I loved it. I'm pretty sure everyone loves differentiation. Integration, we hate it. Right? So there were certain things like that. So exam start ho gaya. First 10 minutes, don't know what happened. I was like, my hands were shivering. Literally, my hands were shaking. Like this, my hands were trembling. That never happened before. Matlab, koi bhi exam it didn't happen. For some reason, my hands were literally trembling. I didn't understand. I was blanking out. Matlab, soch raha tha chemistry mein inorganic questions I'm reading and I'm not understanding what I'm reading also. Then I just kept the pen down. I think it's already 5-7 minutes ho gaya. Then I started talking to myself. I said internally, like, what's happening? Like, I said, what is happening with you? I said, like, not sure what is happening with me. There's no one else to talk to, right? So I started talking to myself internally. I said, "Theek hai, happens. This we prepared for. I know I'm going to panic. We planned for all this stuff. So what is the first thing that we do?" So I had few things. So my logic was this: why do I panic? Because I started thinking something negative. That agar exam mein kuch ho gaya, that will happen, this will happen, and I started panicking. So I need to first of all get away from the exam. I need to disconnect everything. So I tried few things. One thing was like, started counting numbers from back. 100, leaving three numbers. You have to make it tough. You have to make think. So 100, 97, 94, 91. See, you have to think subtracting 3. You just can't do it automatically. So normally this used to work. That day I counted all the numbers. It didn't work. I'm still little on panicky mode. Then I said, okay. And then the last thing left was, this also I planned. Like, I take a deep breath. I told you this multiple times. You take a deep breath and hold it in. Right. For me, 60 seconds not used to work because I got used to 60 seconds. So I used to hold breath for 90 seconds. So take a deep breath and just holding my breath in for 90 seconds. First 30, 40 seconds, nothing happens. Next 30 seconds, you're struggling. Last 30 seconds, you're thinking of only one thing. When will the time get over? I want to breathe or I'm dying here. And I think when you're about to die, because of lack of oxygen, you won't think about the exam. Right? I think at that point of time, any bloody exam, it won't matter. The only thing you're thinking in the last 30 seconds is, when will I breathe? There, literally, I have disconnected myself from the exam for 30 seconds. That's what I wanted. I wanted a break. Now, the important 90 seconds got over, and I'm gasping like breath and all. And the guy beside me is looking at me like this, like, Kya kar rahe hai? Who the hell is this guy? The people do look weirdly, but and then now that is the important thing. Now, once you are out of it, don't wait for too long. You have to get back on track. If you wait for another 2-3 minutes, again you'll go into the negative cycle. Then I said, like, okay, fine. Whatever happened. By this time, I think I already wasted around 12 minutes, 12-15 minutes ho gaya tha. I did only 2 questions of chemistry. Almost 12 to 15 minutes done. 12 minutes to minimum ho hi gaya tha. I lost almost 3 questions I did. That's it. I said, ठीक है, let's do this. कुछ नहीं होगा, ये नहीं तो कोई दूसरा एग्जाम देख लेंगे. You go ahead करके. I was talking to myself and I started the exam. Now it is a race with the speed, okay? Because I know lost time. I was rushing. I was doing one after another. I finished the paper. I did 179 questions. Once I went back again and saw the first 2 questions, I was laughing at myself like, what the hell was I thinking in the beginning? I know every damn thing there. वो एक क्वेश्चन पे मैक्स में छोड़ दिया था. I finished everything. हाँ, silly mistakes तो हो गया ही. I scored around 421 or something out of 540. Right. This was All India 179. So that gave an AIR of 179 and state 33 rank. Now I'm seriously telling you, I planned for it. I know I'm going to panic. If you don't go to an exam with a plan, like, seriously think about this. Yeah, these exams are life changing for you. Why won't you panic? And people come and tell me after the exam, sir, I panicked in the exam. I said, don't you know you're going to panic? Then what did you do about it? What plans did you do to go and fight about that? सब लोग academically plan कर लेते, but who is going to plan for your these breakdowns and everything? That is a difference. I planned for it. I learned how to talk to myself. I created an alter ego because I need someone to talk to, and there'll be no one allowed in the exam. So I need to talk to myself. It might look like madness. It helps. Second thing, I devised techniques. I knew I'm going to panic. So what should I do? Holding my breath always worked. For that, I have to put some thought. Why am I becoming negative in the exam? So what should I do to break that negativity? What should I do after that? What happens if after 2 times back to back? So the third plan was that I had to go to washroom. If that breathing didn't work, I would have gone to the washroom for a 5-minute walk. I would have wasted more time, but that is much better than actually doing the exam. Because then, even if I wasted half an hour, I still have 2.5 hours. I would have still done 160 questions. I would have just sped up more. That is there. Your subjects will always come to help you, but as long as you are calm and mentally sane. In the exam, you go and become mad and breaking down, then no one is going to help you out. The only person who can talk to you in the exam is yourself. Unfortunately, we don't do that anymore. You have a problem, we'll talk to parents. You have a problem, you'll talk to teachers. You have a problem, you'll talk to a counselor. You have a problem, you'll talk to your best friend. Bloody the one person whom you need to talk is yourself. Who knows the problem? Who knows everything about it? We won't talk to that bloody person, we'll talk to everyone around it. Anyways, how to do this thing? So keep these things in mind, what I said. Now, I was really proud of myself after the exam, not because I got a good rank, but the way I handled myself. After the exam got over, I knew I cracked the exam. I doubt ही नहीं था. I didn't even check my answer key. I knew I did the exam. I didn't expect such a good rank. I was expecting around 400. The 400 also I was expecting because during that time, if you get AIEEE less than 400 rank, you get a scholarship. You get 1,000 rupees per month for 4 years during your engineering. And I wanted that scholarship. because money was always an issue. So that much I was sure. 179 state 33. वो सब तो when I got the result, I was playing in the ground, rolling in the mud and all. We are playing some stupid game. वो होता है ना क्रिकेट नहीं है. You throw the ball on each other and you beat each other. कुछ तो बोलते हैं उसका. Don't remember. तेलुगु में we used to call it beeps up. Beeps up मतलब we'll take the ball and bash you right and left. Something like that's what it means. So I was in shorts without chappals with and rolling in the mud. My dad came and said, "You got a call from your college." I said, "What happened?" There was some exam, na result came out. They're calling you immediately. I went home, took bath, got ready, and went there. Then my principal said, "You got so and so rank." I and another 2, 3 people are there. So there were like around 5 people in my batch, I guess, who got less than 400. So they're taking photos of all of us. None of our photos came. My principal got photo came. I said, like, what the hell, yaar? We wrote the exam and principal got photo came. The saddest part of that meeting that day was the journalists who came, they got the gifts. They were given samosa. They were given cool drinks. And bloody we got the rank. We are just standing behind the principal. We didn't even get a samosa to eat. I got so pissed off. I said, I'm walking away from here. And later they did give us samosa and a cool drink. I was like, fine. It is worth it. So how do we take this thing? So resolve this into two components. I think 20 years back now, we students used to be very simple creatures, I guess. So here what happens? V cos theta is unchanged. This V sin theta will start going in a circle. So if I split this V sin theta will go in a circle. And this V cos theta will go straight line, undeviated, because it is parallel to the magnetic field. So if you actually look at this circle, right? It would look like this. The center will be this coordinate 0, 0, minus r. That's your minus z axis. So this circle is going in YZ plane. So if I just make it like this, so this is 0, 0, minus r. So at any instant here, this is theta. This is your radius where r is equal to mv sine theta by qb. And time period will be 2 pi m by qb. You want pitch. Pitch is nothing but the horizontal velocity v cos theta into time period. So pitch is simply the distance between the two threadings, or that horizontal distance traveled in one time period of revolution. And how do you get the coordinates? So this coordinates will be, this guy is r cos theta, this is r sin theta. Remember, this is your y and this is your z. So this is 0, y coordinate will be r sin theta, and the x coordinate will be minus r into 1 minus cos theta. That's your x coordinate, y and z, and your x coordinate will be v cos theta t. So if you had given that electric field, it would have been v cos theta t plus half at square. There, you're done everything. So you got x coordinate is v cos theta small time. Your y coordinate is r sin theta. Wait, I shouldn't have taken theta here. Let this be alpha. R sin alpha t, and z will be minus r into 1 minus cos alpha, where alpha is equal to omega t. So omega will be 2 pi by capital T into small t. Or you can calculate that, which is v sin theta by r. Clear with this? Is everyone getting how is that circle going on? So the force will be towards the negative z axis. So the center will be at 0, 0, minus r. So you can split the motion into a circular motion plus a straight line. Let's get these two. There is a magnetic field B out of the plane. There is a mass m, charge q. Velocity is v. Find the electric field if the particle is undeflected. We have a very tall building, gravity is present, the particle is released from rest. Consider the Earth's magnetic field, and in which direction will this particle move? Meaning, will it go left? Will it go right? Will it go straight? Will it go towards south? Will it go towards north? ऐसा four options होगा. Basically, if you see in 3D, this particle is going towards the center of the Earth. So, in which direction will this particle go? Let's say this is happening at the equator. Will the particle go towards the north, east, west, south? Get the fifth one. That is an easy one. Do you guys remember? There's a name for this thing. There's an experiment for this thing. It's called velocity selector. Remember that experiment, J.J. Thomson experiment? It is the experiment to find the ratio of Q by M, specific charge. So there is an experiment on this called velocity selector. Yeah. And it gives you a very good formula for units and dimensions. Velocity is equal to E by B. So the ratio of electric field by magnetic field is velocity. So that was the answer actually. Let's get this. So what is the answer for the first one? So QVB, the magnetic force will be downward. So if you want to cancel this, you need an electric field here in this direction, QE. So there is a one thing here. You can also have yeah, that itself, I guess. QE will be QVB. So E is equal to VB. And the direction must be up, J cap. Clear with that? In this thing, now they can ask another kind of question. If there's an electric field and a magnetic field, what is the minimum speed for no deflection? Right? This V will be the minimum speed. Even if you have a component along B bar, it won't affect the problem. What about this thing? Now, for the B part, you should know something. Do you guys remember this in magnetism I taught you? The Earth magnetic field will go from which direction to which direction? That you should know. If you don't know that, you won't be able to do. The Earth's magnetic field goes from south to north. This is your BH. This is the Earth's horizontal magnetic field. Anyway, the vertical component won't affect the problem because they're in the same direction. So your velocity is minus GT J cap. Your magnetic field is going from, I'll do one thing, wait, let's take it as, so this is east, north, south, west. This is up and this is down. So for convenience, let's take this as X. This is Y and this is Z. So your velocity is minus K cap. Your magnetic field is J cap and you're asking for the force Q V cross B, which is minus K cross J cap. What is K cross J cap? I cap, na? That means the force is going to go east. So this particle will come straight and it will start bending like this. It's just not going to fall straight, it will bend towards east. Clear with this? There. So it's very feeble, but it does happen actually when you throw charged particles from, as the speed increases, the magnetic force increases. So the deviation will increase more. As it is coming down faster and faster, the deviation would increase. Clear with this? Question is easy, but you should know the 2-3 points there. Now, if you don't know about this horizontal magnetic field, you won't be able to handle this. So it's a good one. Yeah. Let's get these four. We have a loop there, magnetic field B, current I is passing, find the force on the triangle. Here the current is entering here and current is leaving from here. Find the force on the loop. Current is going in a circle, find the tension in the ring. We have done that before. Infinite wire and there's a parallel perpendicular wire I, find the force on the wire. Get them four. Actually, this is a disc. That's not a loop actually. I could have taken the loop also. Disc is better. Finish off. I'll give 2 minutes for all. 2 more minutes. Like I said, these are the kind of questions you see and you know what to do. That knowing, right, should not take more than 10-15 seconds, and solving can take another 1 minute. So that is the thing. But if you're taking a minute to figure out what to do, what is there, and then you're already slow. No, again, this I'm talking about standard questions. You should be that clear. Let's see. Now, these questions, right? Do you guys remember this projector length? If you have any random loop, random curved wire, and if a current I is flowing, the force on that curved wire is simply I L cross B, where L is the projected length. You simply join it from end to end. This is valid if B is constant. So it really doesn't matter how the current flows. What matters is the entry point and the exit point of the current. Are you clear? Now, if you know that, then it becomes pretty straightforward to do this. So for this guy, the entry point is this, the exit point is this. So for the upper part of the wire, this is the projected length, L only. Getting it? So actually what happens here, the current will split. This will be I by 3 and this will be 2I by 3. You can actually calculate individually and do that, but you need not do all that. So between this and this is the projector length. So this entire triangle can be replaced with one wire of length L. So it doesn't matter how the current flows here. I1, I2, this is I1 plus I2. The force will be ILB, IAB. Done. Same thing here also. The entry point, exit point, just join them. So actually here what happens, right? The current will start going in some random loops. And we don't know how it is flowing also. We don't need also. Because for all these random wires, the line AB is the projected length. So this A and B is your projected length. So you can just replace all these wires with AB, whose length will be R root 2. And you can assume current I is flowing through this. And there's a magnetic field B here. So this is I L cross B. The force will be this way. I R root 2B. Is that making sense, everyone? So only the entry point and the exit point will matter when B is constant. And then if you do for this guy, for this loop, I hope you remember we did that for small d theta, but you can do even better. Take only half of the ring. If you take half ring, current I for this is the projected length. So the force will be I 2R into B. This will be tension, this will be tension. So T is equal to IRB. So you'll get it even faster without doing all to that, sine d theta by 2 and all that stuff. If you take half the semicircle, the projected length will be this. You should definitely go and check out the projected length concept. Told you this will come in 6 chapters. Projected length and area together. And for the fourth one, yeah, we can't do. For the fourth one, you have to integrate. There's no way out. Because B is changing. This is I. This is small I. At a distance x, take a thin piece dx. So the force acting will be integral I dl is dx. The magnetic field will be mu naught capital I by 2 pi x. The limits will go from A to D plus A or L plus A, whatever is the distance given. And how will the force be? The magnetic field is this way. So the force will be up. They can ask you this question also. A simple question would be this. In which direction will the wire move? North, south, east, west. Which direction will it rotate? Clockwise, anti-clockwise. ऐसा 4 options होगा. It will move up clockwise. It will move to the right anti-clockwise. They'll make 4 options like this. Now, if you look at this wire, the force will be like this. This part will experience more force because there's more magnetic field, and as you go, the force decreases. So this wire has a tendency to rotate clockwise. So if that they ask you that question, which way will it move? It moves up and rotates clockwise. Is that clear, everyone? That itself is a very simple theoretical question. Clear? So these are some good ones. So you should definitely know them, how to handle them with projectile length. Let's get this thing. We have a fixed infinite wire and there's a small wire of linear density lambda and length L. Distance is d, current is I, gravity is present. Find the distance between them for equilibrium and find the time period for small oscillations. And remember this thing, the moment you hear the word equilibrium, SHM will follow up. It doesn't matter which chapter. SHM will simply come and hijack. Actually, the previous question also I could have asked you. I'll do that in advance. Like, I will say this ring which is there, this is actually an elastic thread with spring constant K. If I increase the current by Di and release it, this ring will oscillate in and out. Find time period of oscillations. Anyways, we'll see that later on. For now, this much is fine. Let's see. So if you look at the magnetic field here, due to this guy, it will be out of the planes. So that is IDL cross B. So this will be ILB and this is your MG. So ILB will be mu naught capital I by 2 pi D. This will be mg, where m is nothing but lambda lg. From here, you get d ka value. Now for the second part, what you do, you displace it by small x. Now let the distance become d plus x. Now if you see the net force acting on this will be mu naught I small I by 2 pi d plus x minus mg is equal to ma. Take out d common. That will be mu naught I by 2 pi d 1 plus x pi d minus mg is equal to ma. But I know mu naught I by 2 pi d is nothing but mg only. So that would be mg. It goes up, you do binomial approximation. 1 minus x by d minus mg is equal to ma. mg cancels off. We get a is equal to minus g by d into x. That's your omega square. So time period is 2 pi root over d by g. Clear what I did? So this term here is actually mg only. Clear with this? That's the time period for small oscillations. I would have asked you that question directly without asking equilibrium. You need to find that anyway. Because it is x is small, you can do the binomial approximation. Let's get this thing. We have a big ring, we have a small ring, coaxial, distance between them root 3r. Radius of the big ring is much greater than small a. The mass of the small ring is m. Find the time period for small oscillations, find the mutual inductance between them. Hope you guys remember what is mutual inductance. Let's see. First of all, I hope you remember the magnetic field formula for this big ring. Without that, you're lost. And exam is sometimes that formula itself is a question. B is equal to mu naught capital I r square by 2 into r square plus x square whole power 3 by 2. Yaad aaya? This is the magnetic field as function of x on the axial line. And if they ask you to plot the graph, be careful, huh? Don't get confused this with that electric field graph. In this case, the maximum will occur at the center only. The value will drop on both the sides. The maximum occurs at the center, not at r by root 2. So this is how it will look. So at this point, we have the magnetic field here. What did I ask you? Time period, na? So displace it by small angle theta. So if you displace this guy by small angle theta, this will be your mu bar, this will be your b bar, and this will be your theta. What is mu bar? NIA, magnetic moment. The torque will be mu cross b bar. which is NIAB sine theta, right? And torque is equal to I alpha. This is NIA small b, small angles, it will become theta. What is the value of I? This is important. Huh? People do everything in the goof of this and come. What is this I? It's just a ring, okay? So what is I? Array, not that record. This is moment of inertia. Array. Torque is equal to I alpha. Hmm. What should I write? I already used capital I everywhere. That this is moment of inertia into alpha. What is this moment of inertia? One is like it is a current in the big loop, it seems. No, you're not wrong, but I didn't ask you that. Kya the moment of inertia? It is rotating about which axis? This is the moment of inertia about diameter. Look at that ring, how it is rotating. If it is rotating about the central axis, it will rotate like this, right? This is rotating in this plane. The axis should be into the thing. So this loop is actually rotating about the diameter. Are you getting it? So this is the rotation about diameter. So that moment of inertia is mr square by 2. So that would be mr square by 2 alpha is equal to NIAB theta. So you will get alpha is equal to minus omega square theta. This is your omega square. Are you clear, everyone? So this will produce the magnetic field on this loop, whose value can be calculated from here. And from there you can get that also. What if I ask you the force between them? If I ask you find the force between them, then what will you do? That will be a really good question. Huh? If I ask you find the time period for small oscillations, find force between them. No, this will start entering into advanced region, but anyway, even this still didn't look that easy anyways. So you need to know three things here. So you need to know the magnetic field ka formula. You should know that mu is equal to NIA and torque ka thing, and then your SHM ka mode rotational mechanics. Right, Vihan. So force, right? There is no direct way to get the force. You have to do it this thing. You will say, you'll find the potential energy, U. Potential energy will be minus mu dot B. Initially, anyway, theta is 0, so mu B. Then you will say force is equal to minus du by dx. Yeah? From there, you'll get the force. There is no other way out. You cannot calculate the force on that thing. And you can do all this because that's a very small loop. You can assume B is almost uniform. Clear with this? You want torque, mu cross B, right? If you want force, you'll find the potential energy minus mu dot B and then differentiate it with respect to x to get the force. Clear with that? So leave the thing in terms of x, differentiate, and then substitute x is equal to root 3r. Don't substitute in the beginning. All clear with that? So there you can find the force, you can find the torque on the ring. So this is the force on that small ring due to the big ring. And how do you find the mutual inductance? We'll find the flux. Flux will be B into area, B into pi r square. That will be equal to mutual inductance M into Y. So this M is your mutual inductance. There are too many formulas messing up. So be careful here. M is mass, M is mutual inductance, capital I is current, capital I is moment of inertia. So all clear with this? Clear, no, Ashwin? Confused? If the ring radius is small, why can't we neglect it and find force directly? Find the force and tell me. What will you take? IL cross B. What is L? 2R. 2 pi R. The force will cancel out every direction. The current is going up and coming down. So in your logic, the ring, if you take like a wire, it is like up and down current, net current zero. Let's get this thing. We have a charged ring, current nahi hai. Charged ring Q rotating with omega. Find the ratio of electric field by magnetic field at point P. We have done this. So this formula, na, if I have to just write it down, we'll get time period is equal to 2 pi root over I about diameter. So in this question, na, most people I saw they goof up the diameter. Because the moment you think about a ring, you'll say mr square by 2. We will not think too much. Nah, there is a high chance even I will goof up though. So be careful with that. So you know how to find the electric field, right? And if a ring is rotating, it behaves like a current loop. So you can do that also. So what is the electric field? Electric field is k q x by r square plus x square whole power 3 by 2. What is the magnetic field? Mu naught I r square by 2 into r square plus x square whole power 3 by 2. When you divide them, numerator may go solve. This will be k cube x by 2 into mu naught I r square. How do you find current? I is nothing but charge by time, which is 2 pi by omega. So that is 1 by 4 pi epsilon. Yeah, I think 2 will go up, na? Yeah, I think so. 1 by 4 pi epsilon q. X is anyway root 3r by mu naught. I is q omega by 2 pi r square. 2 pi 4 pi goes off. Q goes off. There's an r square also. Q root 3r. So that would be root 3r. And r also goes off. This will be epsilon mu naught r omega. But I hope you guys remember what is root mu naught epsilon naught, speed of light. So if you square on both sides, this will be root 3 c square by r omega. That's your answer. So exam mein, the toughness of this question is not the formulas. The final answer will be in terms of speed of light. And most people won't understand like where the hell the speed of light came from actually. Clear with that. So that 1 by root mu naught epsilon naught becomes speed of light. That's the important thing. Clear with this? Question and moon to finish is ma square by 2. Yeah, I took that radius wrong. Yeah, right. My mistake. All clear with this? 1 by root mu naught epsilon naught. Don't forget that. Quite an important thing. Let's get these things. We have a cube there. See how the current is going. The red line is the current ka flow. Find the magnetic moment of the cube. Solid sphere rotating with omega. Non-uniform disk rotating with omega. We have a cube with 8 charges on the vertices. Find the angular magnetic moment for all of them. Find mu for all 4 of them. In case of bar magnets, this mu only we call it as m bar. In bar magnets, it will become capital M. The formulas and all will kind of same, but let's get these 4. First is a really good one. C is just little working. D would be a decent main. D and B would be good mains questions. If it is a mains exam, I would ask you maybe A also. A, B, and D. C, so if I decide to harass you, I might ask you little C also. You guys will be able to handle it. But people who are not good with calculus, normally this they will have a problem. Mostly C, so they will avoid generally. Because you need to understand the examiner who's setting the paper, he wants to make sure the students who didn't have any coaching, who studied only in Kendra Vidyalaya, NCERT board, CBSE board, even they themselves, they should be able to handle to get at least 70 marks without any external coaching. That's the mains paper ka mindset. So they're not going to ask you something so out of the world that, in order to test you guys, they won't, slaughter the other kids from rural areas. First is a good one. Let's see how do you handle that. Right. Yeah. Let's see the first one. Now for the first one, we need to get a loop. And if you see, this is nothing in the loop. So this is what we do. Assume one wire here and one wire here, the green ones, and assume one wire here, and let's assume one wire here and one wire here. So you can assume current I and plus I, so that's the zero current. And now let's create loops. So we have this loop. So this is constructed out of one green wire and one black wire. So there you created a loop. Remember, you can use the wire only once. Then if I use this one and this one, so this I'll use the another green wire. So there I used up all the green wires. There I used up all the black wires. I used up all the sky blue wires. Making sense what I did? By imagining 6 imaginary wires, I could create 3 complete loops. So this thing is rotating that way. So this would be the mu bar, which is n I area. Area is a square. That would be minus I cap. This would be into the plane. This would be down the thing. So there. So mu bar of the system will be n I a square minus I cap minus j cap minus k cap. Clear with this? N is the number of turns. I think I didn't give you that. So simple n. I hope you got this thing. That's how you handle these kind of questions. When the wires are not forming a loop in a plane, you're getting it. The problem is that they're not forming a loop in a plane. You have to bring them into the same plane. You have to do that by imagining, wires. Clear with this? That's a pretty good thing. Don't add them up. I shall be careful. Directions also will matter. What about the other three? If you look at B and D, they are easy. Do you guys remember the formula? Quite an important formula is there. The magnetic moment mu bar is equal to Q by 2m into L bar. Yeah, the relation. This is the relation between the magnetic moment and the angular momentum. Anyone remembers what is Bohr's magneton? याद है कैसे सुना था? What is Bohr's magneton? The magnetic moment of the electron in the first orbit of the hydrogen atom. Right? So you have to just put L is equal to nh by 2 pi, where n is 1. That is the angular momentum in Bohr's theory. MVR is equal to nh by 2 pi. It's called Bohr's magneton. They did ask this in CET last year or last year, I don't remember. Magnetic moment of an electron in first orbit. So we know MVR, L is equal to MVR is equal to NH by 2 pi. You just put N is equal to 1, substitute there, you'll get the answer. You're done. What is the moment definition of a solid sphere? 2 by 5 mr square. So L is equal to I omega. What is the moment of inertia of this thing? These particles are at a distance of a by root 2. So the moment of inertia will be m into a by root 2 ka whole square 8 times. The angular momentum will be I omega. Got this? Substitute there, finish it off. And be careful, this m is the total mass. Don't take for one particle. So in the second case, that would be 8m. Clear, everyone? So there's no need to calculate for each and everything. You just get the moment of inertia of the system. I into omega is angular momentum. Take that and dump it in the formula, you'll get the answer. What about the C part? Now, C part, non-uniform distribution, you can't do that. You have to integrate. So how do we do that? At a distance x, take a thin ring. So let's find the current in the ring. The current in the ring is the charge on the ring by time. Charge of the ring will be sigma naught x into the area, which is 2 pi x dx by 2 pi by omega. The magnetic moment of the ring will be I ring into area, which is pi x square. So mu of the disk will be integral. The 2 pi will go off sigma naught omega x square dx pi x square from 0 to r. This is sigma naught omega r power 5 by 5. Clear with this? You have to take a ring, find for that particular ring, and then you integrate. Now imagine if you don't know that formula and you have to do for a solid sphere, you will die. For a solid sphere, first you have to find for a hollow shell, or you have to find for a disk, and then you have to integrate all the disks. It's really complex. It takes a lot of time if you have to integrate for a solid sphere or a hollow shell. Disk is फिर भी manageable at a mains level. So if it is an advanced question, right, and they really want to make you just calculate a lot of stuff, I'll do this thing. I will say we have a solid sphere whose charge distribution is rho is equal to rho naught r. You're dead. Matlab, gaya. Then you can't use that formula. You literally have to first integrate for a shell, and then you have to integrate for a sphere. That would be a double integration. It would involve a lot of time. Doable. It is just lengthy. It is not tough. Disk is manageable at a mains level. Clear with this? If I can do the question in 5 to 6 steps, it is still a mains question. Let's get these 4. We have a charged particle Q going with velocity 3i plus 4j, which is at 2, 3. Find the magnetic field at the origin. We have a finite current wire. I, it is making angle 30-60 as shown. Find the magnetic field at P. Find the magnetic field at the center. Find the magnetic field at A, D, D. Q is equal to E. Q is equal to E. The first one, you know the formula, you know. You don't know the formula, you're gone. If you remember, we did that. Magnetic field due to a moving charge. Biot-Savart's law ka, modification tha. You guys know Biot-Savart's law, right? And the second one is also a formula. Third is a good one. So you should know the finite wire ka formula. Unlike electrostatics and gravitation, magnetism में the finite wire formula is decent. Interesting. People are increasing slowly. Maybe they slept and woke up. Happens. Anyway, in case you're feeling tired and sad, remember Wednesday we don't have a class. That should give you motivation to focus. No, seriously, what is a festival without a holiday? So that is the thing. 52. Okay, maybe it could be. I don't remember the answer. How to do the first two? Should check out the notes. Matlab, this is the formula for the magnetic field due to a moving charge. B is equal to mu naught by 4 pi Q V bar cross R cap by R square. That is a formula for magnetic field due to a moving charge. And how did we get that? If you remember the Biot-Savart's law, mu is equal to mu naught by 4 pi I dl bar cross R cap by R square. You write that I as dq by dt. And then dl by dt ko you make this into velocity. Yeah, something like that. What is the formula for this? The finite wire ka formula magnetic field is given by mu naught I by 4 pi d sine theta 1 plus sine theta 2. This is the formula. But be careful here. Theta 1 and theta 2 are measured on either side of the wire. Theta 1 and theta 2 are supposed to be on either side of the wire. But here they're on the same side. So theta 1 is 60 is right, but theta 2 is minus 30. Do you guys remember that? So when we look at 60 and 30, if the wire was like this, if this was 60 and this was 30, then you will take theta 1 is 60. So theta 1 is supposed to be with the upper side and theta 2 is supposed to be the lower side. So the derivation, when we did, right, in that derivation, we substituted the limits as minus theta 2 to plus theta 1. Because of that, the formula it became plus. I hope you remember that thing. So that's a small trap. You have to be careful. Don't put blindly 60 and 30. It is 60 and minus 30. It matters like which way the angles are. What about C and D? If you look at C, right, it is simply 3/4 of a circle. Most people will think that only. You have to be careful. Plus a infinite wire, semi-infinite wire, isn't it? This wire is useless because it is passing through this. So there are two wires also. This will give B 0 because it's passing through the axis. Due to this wire, it will be out of the plane mu naught I by 2 pi R k cap. And due to this guy, the field is mu naught I by 2R, 3/4 of it, because only 3/4 of the wire, that is also k cap. Add them up, you'll get the answer. Clear with this? So one of the most common mistake, right? People forget this wire. They'll just take the 3/4 of the wire and they'll get the answer. If you want to ignore that wire, how should the shape look like? It should look like this. If I draw like this, then you can ignore those two vertical wires. Hope you're getting it. So be careful with that. That's a one pretty good trap. They will do that. Not tough, but we see only the 3/4 of a circle. We ignore that wire, so we have to be careful. What about this guy? This is also something similar. So when you drop a perpendicular here, this is the distance. This angle is 90 and this angle is 45. So the formula will be mu naught I by 2 4 pi d sine theta 1. That will be sine 45 plus sine 90. Because there are two of them into 2. The direction will be k cap. Clear with this? That would be a really tough question if these were charged wires and if you ask you electric field. Luckily here both the wires ka direction is same, you simply do it into two. But in case of an electric field, the fields would be in some weird, you have components this way and this way. I cap, J cap and two components aega. That would have been a little more work. All clear with this? And this thing also, be careful. This is valid for uniform distribution only. Let's get these two. Hope you guys remember the spiral. Spiral comes three times. You can ask the magnetic field at the center, you can ask the magnetic moment, you can ask the magnetic flux in EMI. All three cases, the idea is the same. Second thing, you took a solenoid, you rewound to R by 3. Find the ratio of magnetic field, self-inductance, magnetic moment, magnetic energy density, and energy stored. Let's do one thing. Take a break. Come back by 7:35. Then we'll continue with this. Take a break. Get away from the screen at least for 5 minutes, and then come back if you want to do it. You can do. Now let's get this. Yeah. Let's get this. This is a good one. These are 8 questions. Hmm. Try. Another 2 minutes. I'll show you all. Let's see. So, first thing, how do you handle this? We take at a distance x, we take a ring with a small thickness. So, number of turns in this dx. And so, this is the main important thing. Will be the total number of turns by width, which is b minus a. So, in a thickness of b minus a, there are capital N turns. And the thickness for this thing is dx. So, the number of turns are dx. So, in a ring of radius x, there are this many turns. Done. So what do you want to find? Magnetic field. So this will be integral. The magnetic field will be dB. So the magnetic field due to this ring will be mu naught I by 2, mu naught I by 2r, which is 2x, into the number of turns, which is n by b minus a dx. Integrate this, will get the answer. You want magnetic moment? D mu will be number of turns, that is n by b minus a dx, into the current into area pi x square. Integrate this, you'll get the magnetic moment. You want magnetic flux, the flux will be the magnetic field B into the area, which is pi x square, into the number of turns n by b minus a into dx. Integrate this, you'll get the total flux. Clear with this? So this is the magnetic field due to the ring. This is the magnetic field due to the magnetic moment. This is the flux in the ring. So in that ring, there are this many turns. Clear with this thing. That's how you introduce the dx term in the integration. And once you integrate this, you'll get the answers. Limits will go from where to where? A to B. All clear with this? That's how you do, spiral curvations. Main thing, get the number of turns and finish off from there. What about this thing? Whenever you do rewinding, what does not change? What does not change? Number of turns per unit length. So this thing has n turns and length L. This will have now 3n turns and the length will become 3L. So small n, which is number of turns per unit length, will not change. Basically, the number of turns per unit length will depend on the thickness of the wire. And then you're done. For the first question, magnetic field B is equal to mu naught Ni. Nothing changed. Constant. So we get 1:1. You want to find self-inductance? Do you guys remember the formula for self-inductance? L is equal to mu naught n square pi r square L. So mu is constant, n is constant. So this is proportional to radius square and L. So L1 by L2 will be r square length L. This guy is r square by 9 into 3L. 3:1. Magnetic moment will be total number of turns, that is capital N, into magnetic field, which is mu Ni, into area pi r square. That's your total flux. What am I finding? I think I'm finding flux, I guess. Mu is your... That's also a good question, right? You can actually find flux. So this guy becomes... Actually, that is only B ka question. Because remember, flux is equal to Li, which will be same as the mutual inductance. So you need not do that. It is same as that only. If they ask you find flux, say flux is equal to Li or proportional to L. So L ka answer will be that only. So what are you trying to find? So this thing mu bar, which is Nia. Ni area is pi r square. So yep, number of turns will be, that is n into L. N Li pi r square. So this is also proportional to r square L. Okay. So you can do that. Magnetic energy density, remember the formula? 1 by 2 mu naught B square. This is constant. B didn't change. 1:1. Energy stored. Energy stored is half Li square. So proportional to L. So the same answer as 3:1. Got it? So if you want energy stored or flux is Li, energy stored is half Li square. So get the mutual inductance, self-inductance and finish off from there. That would be faster rather than calculating individually. You guys know the dimensions of self-inductance? How will you find dimensions of self-inductance? Again, need not calculate. Just think about the formula. Which formula will you use to calculate, boss? If you know that, you'll be able to handle in the exam. Whenever they ask for units and dimensions, if you can get a formula, appropriate formula in terms of mechanics, it is always easy to handle. Which formula will you use for self-inductance? Energy. Energy is equal to half Li square. So L is proportional to energy by current square. The energy is MLT minus 2, ampere minus 2. No, that was easy. Resistance के लिए? Resistance के लिए which mechanics formula will you use? If we say V is equal to IR, then I'll ask you for voltage. Time constant. Time constant is R into C. C के dimensions पता है तुझे? Power is equal to I square R. Right, Yashwant. Power is equal to I square R. That will be easy, right, Ahna? So there. So always figure it out. Let's get these three. We have a one turn ka wire of current I. You made into n turns. Find the ratio of magnetic field before and after at the center. You have a spring. You send a DC current. You send an AC current. What happens? You have a system like this. Find the magnetic field at the center. We have two current wires I and I going into the plane. Plot BX versus IX. Hope you guys remember those graphs. We did in electrostatics also. So take J cap as positive minus J cap as negative for direction. The first one was a very common question. Let's see. So the magnetic field for the first guy will be mu naught I by 2R. Now for this guy, the radius will become R by N. So this will be mu naught I by 2 R by N. And remember now there are N turns, so into N. This is N square, initial value B. So B1 is to B2 is 1 is to N square. If you send a DC current, what happens? This thing, you can treat each ring, the entire spring like rings. So when the current is flowing in the same direction, you can treat them like magnets. So it's like north, south, north, south, north, south. If you see the opposite poles are like this, so they will attract. So if you send a current in the DC, the spring will compress. But if you send an AC, what will happen? Whenever the current flows, it will compress. When the current becomes zero, it opens up. It oscillates. Remember I told you how to catch snakes with this. This is actually what happens inside a transformer. If you remember in a transformer, we have these coils now like this. The primary coil and the secondary coil with a lot of turns. So when you're sending a current there, the coils actually oscillate. Whenever the current is going in and out, the coils are oscillating continuously. So if you go near a transformer, right, you'll hear a buzz. There's a sound like this when you're close to a transformer. I don't know if you ever heard it. Nowadays, meaning the transformers are quite hidden. Previously, they used to be on the road, so you could actually hear when you're walking beside. That oscillation is actually because of this coil's oscillation. And this frequency, right, is around 50 hertz. And I told you this thing, if you put this transformers in a rural area, in a forest area, right? These vibrations will travel through the ground, and the nearby snakes, right, in that area get attracted to this thing. It's like the transformer is calling them, come here, I'm here, karke. And the snakes love the transformer. Two reasons. One, it is vibrating, so you know the location. Second thing, transformer produces a lot of heat. Anyone remembers what heat is that? Again, be careful before answering. What kind of heat is produced inside a transformer? The first thing you thought is not the answer. Aditya got it. It is, what kind of losses it is? It is eddy current losses. Copper losses nahi hai. Copper losses will happen where? That will happen during transmission. Once the current goes from the transformer through the wire to the city or to the house or something, the heat dissipated in the wire is called copper losses. Right? And when you have a, some coil or anything, and when there's a heat produced, when you send a magnetic field through a metallic, right, there will be a random currents which are generated, which will produce eddy current losses. There's a third thing called hysteresis loss, which we removed in the motion. But whenever you try to take a magnet and try to magnetize and demagnetize a substance, it produces heat. It is called hysteresis loss. So there are three types of losses there. So if you take a metal, try, send a magnetic field and try to make it a magnet. So all the poles will turn in one direction. When you remove that thing, the poles will turn back. In this process of turning the poles front and back, you produce heat. This is called hysteresis loss. What about this guy? This thing, if you remember the formula, mu naught I pi 2r theta by 2 pi. This will be 1 minus 1 by 2, 1 by 3 minus 1 by 4, so on, minus k cap. This is nothing but ln 2. Yaad hai? That's a ln 2 ka series. So that's an easy one, but yeah. What about the magnetic? What is the graph for this guy? So if you look at this I, so this is, so here on the right hand side it is down, on the left hand side it is up. The same thing here, this is down and this is up. So when you draw the magnetic field, here it is positive. As you get closer to the wire, you'll blow off to infinity. Once you cross the wire, the field is downward, but you're very close to the wire, you're still at infinity. And you get a null point here. And then you blow off to infinity again, and then 0 here. Clear with this graph? Up is positive, down is negative. So whenever, two things, up is positive, down is negative. When you get close to the wire, the value blows off to infinity. And there is a null point in the center. So you will cross the center. If it had been I and minus I, there would have been no null point. उसका ग्राफ कैसा होगा, ड्रॉ करो. Let's say this is plus, this is into, and this is outside. Draw for that fast. I'll give 20 seconds. Left is cross and right is out. None? How will that look like? If you have a cross and if you have a dot, again, same thing. This would have been down, this would have been up. This would have been up and this would have been down. So this will blow off here to infinity. This would be like this. This would be like this. Clear? There will be no null point. You won't touch the origin anywhere. So this graph would be like this at the bottom. Clear with this? Again, drawing a graph is difficult, but in the exam it is easy to eliminate. So you know the options from there, you can check it out. 15a, we did this before, but let's do it again. Let's see how much you remember. We have a ring there, mass and radius are, current is flowing, T1, T2. Find T1, T2, there's a magnetic field. Second thing, there's a solid sphere, you kept n turns and you kept it on an incline, rough, magnetic field is there, gravity is there. Find B for equilibrium. Now I can ask you find frictional force, a lot of stuff. So क्या था वो क्वेश्चन पहले तो should know by now. So the current is going in. So for this thing, the mu bar will be up. Mu cross B, the torque will be into the plane. So basically, if you take this ring here, the torque is trying to rotate this way. This is T1, this is T2. So if you take torque about this point, you can actually take about any point. Mg is also there. Let's take torque about the center. If we take torque about the center of mass, we will get T2 into R plus the magnetic torque minus T1 into R is equal to 0. So this will give you T1 minus T2 is equal to torque, which is mu B by R. Mu is nothing but number of turns Ni area. And we also know T1 plus T2 is equal to mg. Two equations, two unknowns, solve, you'll get the answer. Clear with this? The only thing you have to be careful is which way is the torque rotating you. So mu cross B, right? So torque is into the plane. So actually this thing is trying to lift off like this, isn't it? The left side is trying to go up and the right side is trying to come down. From there you can actually get a feel. T2 will be less and T1 will be greater. What about this guy? Here same thing, when you draw the FBD, mu cross B. Now I didn't tell you which way is the direction of this thing. Let's take it this way, mu. And this is B. So mu cross B, so the torque is this way. If the torque is that way, then the friction would be this way. Agreed? So on the sphere, when you draw the free body diagram, we have friction, we have N, we have mg cos theta, we have mg sin theta, and we have torque. It's not moving, it's at rest, so F is equal to mg sin theta. And if you take torque about center of mass, you can take torque about any point, doesn't matter actually. If you take torque about center of mass, that would be F into R minus the magnetic torque must be 0. So F into R is equal to, this is a mu cross B, that is N I area into B. There you get the beta value from here. Clear with this? F is equal to mg sin theta. Or you could have taken the torque about the bottommost point. That also is faster. Mg sin theta ka torque must be balancing the magnetic torque. Clear with this? And remember, on a loop, the magnetic force is 0. It's a couple. You'll have a torque, but you'll not have any force on the magnetic force due to that. Is that clear, everyone? That's a good one. So there, this is the rotation-based questions on this. Let's get this one. This is a good one, right? We have a infinite current sheet. Sigma is the charge density. It is going with a constant speed v. Find the magnetic field due to a moving charge sheet. That is an infinite current sheets perpendicular to each other. Plot magnetic field lines. We have a toroid. Find the magnetic field inside the toroid. Let me add one more question. We have a hollow cylinder. Radius are long hollow cylinder. The entire surface is charged. Sigma. And this is rotating with omega. Find the magnetic field due to cylinder. So whenever you have charge sheets or charged cylinders rotating and moving, they behave like current loops, isn't it? An infinite sheet moving is similar to an infinite current sheet. A cylinder rotating is similar to a solenoid. There are currents basically. So find the magnetic field due to that infinite sheet, magnetic field due to the cylinder. Plot the magnetic fields and find the magnetic field of the toroid. N is the number of turns. You have all the data you need. C is anyway direct formula. A, D are the important ones. Let's get them. Hmm. Do you guys remember the formula for infinite sheet? First, you should know that formula. Mu naught K by 2. Yeah, where K is the current per unit width. If you don't know that formula, you can't go ahead. The magnetic field due to an infinite current sheet is mu naught K by 2. Let's see. The first thing, the magnetic field ka formula is mu naught K by 2. Hope you guys remember how to get the direction though. Suppose if you have a sheet like this, and let's say the current is like this, going into the plane. Should check the formula in case you forgot. This is the thing. So what you do, choose any one current here, take the point up. So just get the field due to this guy. Due to this guy, it is going this way, it is going this way. There, that's it. You just take any one cross and find the field due to that one, and that will tell you the direction for everyone else. And the magnitude is mu naught K by 2. So here what we will do, so this is a small sheet here. So we will take a small slice like this. So this slice will be dx. So what is the charge on that slice? So current I will be dq, which is sigma into dx into b, that is your area, by dt. That will be sigma vb, right? But what is k? K is nothing but current per unit width, which is I by b, which is sigma v. Therefore, magnetic field will be mu naught by 2, k ka value mein sigma v. Bas. Clear with this? So k is actually sigma v. Got what we did? So I found the charge on the small sheet, which is dx into b into sigma, area, sigma into area. Dx by dt is velocity, so I got the current, but I don't want current, I want current per unit width. So in case you forgot, K is nothing but current per unit width. So here the width of the sheet is B. Same thing you have to do for a hollow cylinder. Remember the magnetic field of a solenoid is mu naught Ni. Now this what we will do now. I will do capital N into I by length L. I'll write like this. So I can write this thing as mu naught by L. N into I will be I total. That is the total current in all the loops. Now from here, what is I total? The current in the cylinder will be the total charge sigma 2 pi RL. That's your total charge by time 2 pi by omega. This will be sigma RL omega. That's your total current. So the magnetic field will be mu naught L by sigma RL omega. LL will cancel. Mu naught sigma R omega. Clear what I did? Because in the solenoid, that small I is the current in the wire. But here it gets confusing how to find the current. I can find the total current in the cylinder. So I will make that small n capital N by L. Capital N is the number of turns into Y. That will be the total current which is flowing on the surface, isn't it? That I can calculate directly. Check it out. These are two good ones. Not tough. If you can see, we can get them in 2, 3 lines, but it can get confusing. So when you have things moving, they behave like current sheets and current cylinders and whatnot. So yeah. What about these two guys? Theoretical formula is straightforward. B is equal to mu naught capital N I by 2 pi R. This formula is only valid between B and A. So only between that region you have field, outside it is zero. What about this thing? Mu naught Ki, again direction matters. So this is mu naught K1 K by 2, mu naught K by 2. This is up, mu naught K by 2 and mu naught K by 2. The green one will push this way. This is mu naught K because K is 2K here. This is mu naught K, mu naught K and mu naught K. So if you see at all the points, the magnitude is same. The direction is different. So the field, the magnetic field would be, they are going like this here in this region. There, this is how the magnetic field lines look like. Clear with this? Because you can clearly see now the resultant, it is in this direction, this is in this direction, this is in this direction. I wrote wrong in this quadrant. Now right. Clear with this? These are some good ones. They'll ask you the direction of the field lines. If you remember, we did this thing in electrostatics. Sigma minus 2 sigma types, magnetic field. Let's get these three. Let's see whether we remember the formulas. Infinite hollow cylinder, infinite solid cylinder, cylinder with a cavity. Find the magnetic field as function of R. Find the magnetic field inside the cavity. Angle would be tan inverse half with x. वो ठीक है. That you can find, yeah. Draw the graphs also. These are important. Solid sphere, hollow sphere. Pressures yaad hai na? Do you guys remember the pressures? Pressure on the hollow cylinder, pressure on the solid cylinder. Hollow cylinder, I told you it is easy to remember. What formula we have to use? Magnetic energy density, 1 by 2 mu naught B square. B is the field on the surface. Solid cylinder ke liye, the formula is different. Mu naught J by 2 R square minus X square, something like that you will get. In case you forgot, na, I taught you that in fluid mechanics when we did that. We wrote all the pressures at one place. See. The magnetic pressure inside a solid cylinder, magnetic pressure in a hollow cylinder, and so on. Let's see. So this will be 0 for R less than R, and it will behave like a wire outside, mu naught I by 2 pi small r for R greater than R. The graph would kind of look like that hollow shell ka result. It would be 0, and then there'll be discontinuity, and then drops. This will be mu naught I x by 2 pi R square. This is for R less than equal to capital R, and this will be like mu naught I by 2 pi R for R greater than R. This will be a continuous graph. This will kind of look like solid sphere ka graph. It will increase linearly and then drop. The cavity ka formula is mu naught J by 2, the magnitude OO dash perpendicular to OO dash. So it depends on the distance between the two axes, OO dash, but the field will not be in that direction. It will be perpendicular to that, meaning if I see the top view, do you guys remember solid sphere में result electrostatics का result याद है? In electrostatic solid sphere का result याद है field का? When I asked you that you should know within 5 seconds, you should not take time. Meaning if you don't take more time, you don't remember. Rho by 3 epsilon OO dash bar. Remember it? Standard result, I don't forget that. So in this, the cylinder, the field is like this. I can keep the cavity anywhere actually. I'll keep it here. So this was O, this was O dash. So the field is perpendicular to this line, OO dash. It's like this. It is constant. The field is constant inside the cavity and it is perpendicular to OO dash. That is the value there. You should know the results. Exam mein mains mein they won't ask you something out of the world. Just forget the results, will be in a problem. Let's get this thing. There's a current wire I here and there's a line AB. Find integral B dot DL from A to B. What is modified Ampere's law? What is the displacement current in this circuit? BNC, well, actually, again, we do that in mains ka thing, but let's do it. They're all related to Ampere's law. Do you guys remember Ampere's law? Integral B dot dl is mu naught I crossing. उसका एक modification है, याद है? If you don't have a full loop, the formula goes like this. If you have a full loop, and if the current is inside, then integral B dot dl is mu naught I. But let's say the loop is outside, then integral B dot dl is 0. But what if it is not a complete loop, but a partial loop? Then it is mu naught I theta by 2 pi. It just depends on the angle between the two corners. I don't care about the shape. Clear with this? You should go and check out the derivation if you need. It's a pretty good derivation. So if you know that result, it becomes pretty easy to solve for that AB. Or else it would take time. You have to integrate. So check out this result again once in case you don't remember. So you just take any two ends, mu naught I, theta is the angle between A and B with the wire. So in our question, you just need to find this angle, which is 45, isn't it? That's it. It doesn't take much time if you know the formula there. And I hope you guys remember what is displacement current. What is displacement current? The current which displaces the charges and the people when it flows through the wire. Yes, sir. What is displacement current? What is distance current? It doesn't exist. Forgot. Displacement current is a pseudo current which doesn't exist. It is just a mathematical manipulation in order to correct the equation. So what about this guy? The formula here is mu naught I theta AB by 2 pi. So from here to here, this angle is pi by 4. So it should be in radians. Be careful. This will be mu naught I. What is modified Ampere's law? The thing is, when Ampere did the experiment and he got the equation B dot dl is equal to mu naught I, what people didn't realize, they thought magnetic field can be created only by current wires and magnets. But later on, as the things improved, we realized you can also create magnetic field by time varying electric field. Remember that? If you have an electric field which changes with time, that produces a magnetic field. We did this thing in EM waves. There's a relation like this. Dou E by dou X is equal to minus dou B by dou T. Yaad hai formula? There is a relation like this. A time varying electric field will produce a magnetic field. So this thing becomes, so this was the actual formula. And this was true if there were no time varying electric fields. But then we had to introduce the term I displacement current, which doesn't exist. I displacement. So this is your pseudo current, which does not exist. It is just a mathematical correction. So this takes care of that, the magnetic field. So now this magnetic field will have two components, the B due to the wire, the B due to time varying magnetic fields, electric fields. So Ampere, when he derived it for the first time, they didn't account for that, the magnetic field can be created by electric fields. So when you introduce that term, the formula started giving wrong answers. Even in a place where there is no current, the formula is showing there should be a current. So in order to correct that anomaly, we introduced a new term which takes care of that. And how do you find I displacement? Again, really not to worry much. I displacement is nothing but that technically the formula is this: epsilon d phi electric flux by dt. Which you actually solve, which comes out to be the regular current only, the current in the wire. So this is epsilon. What is flux? Flux is nothing but q by epsilon by dt. Epsilon will cancel out. This will be dq by dt. This nothing but I conduction or I in the wire. Now in the second case, see what it means. So let's say the current I is actually flowing the wire. So what the formula assumes is, now technically tell me one thing, is there any current between the plates? In a capacitor, there's no current between the plates. But this formula, right, tells you the field in between the plates behaves as if there is an hypothetical current passing through the plates, which is a I displacement, which doesn't exist. So I displacement is nothing but current in the wire only. So don't worry too much. Just calculate the current in the circuit. That is I displacement. How much is that? dq by dt. This is an RC charging circuit. What is the formula for this? CV into 1 e power minus t by RC. So current I will be V by R into e power minus t by RC. That's your displacement current. Clear with this? So you just need to know two things. What is displacement current? It comes because of a correction. People didn't realize an electric field can create a magnetic field. So when they realized it, they needed to introduce a factor which can take care of this electric field. They introduced it by saying there is something called a displacement current, a pseudo current, which doesn't exist. You cannot measure it with an ammeter. But if you introduce this mathematical term, it becomes correct. The equation starts making sense. And when we actually calculate the displacement current, the equation is behaving as if, this capacitor ka plates ka beech mein, there is a current actually jumping directly from wire to wire. That is how it is behaving, even though in reality there's no current between the plates. Clear with this? So the displacement current between the plates is same as the current which is flowing in the wire. So just find the current in the wire using your regular current electricity and done. Are you clear with this? So be careful about that word displacement current. ये questions आएगा. Mains में, bits में, you will encounter this for sure. Now understand, mains में it is not only for you, right? There are like 8 papers. In one attempt and second attempt, there are 6 to 8 papers. In some paper, it will pop up. Now we don't know whose paper is that. And 2 bits is also there. 2 CETs also are there. So it will come in somewhere or the other. Clear with this? Then little bit of this. Let's get these 3. Flux calculations. We have an equator triangle. This is the first question we did in EMI, if you remember. And equator triangle is entering the magnetic field and leaving the magnetic field. Calculate the flux and the EMF versus time graph. Infinite wire, square loop. Find the flux and mutual inductance. I hope you remember this result. Find flux. Finish off. Last one. I'll give you a break. Then we'll have a speed test at 9 o'clock. B and C are easy. Distance x, take a thin slice dx. Mu naught I pi 2 pi x a dx. D2 a plus t. You will get the answer. इसका आंसर is mu naught IR. याद है? It's a big derivation. Check out the notes. That would be an advanced question actually. Meaning I would ask you find mutual inductance and I leave it in advance. Mains में they shouldn't ask this. Integration is a little lengthy but doable though. What about A? Try get A. A is the main one. These two are fine anyways. That B came multiple times. It's a standard question by now. For EMF, I'm taking anti-clockwise as positive. But actually, parabola कैसा होगा? It's important. Most people goof up that part. Think. You draw whatever you think. I'll show you, then you can verify whether you got it. Now we can see this when you're entering. If you take this distance to be x, so here flux will be half into The base will be some, this is 60 degrees, 30 degrees. That will be x by root 3, whatever. So that would be 2x by root 3 into x. So whatever, flux is proportional to x square. And we know x is equal to ut. And when you differentiate EMF d phi by dt, this will be proportional to x and proportional to time. So EMF is a linear function. Great, but when you're leaving, something happens. This would be x, and now flux will be a constant minus some k into x square. It's a minus x square parabola. So now when you plot the graph, check whether you got the same parabolas, flux versus time. So once it starts entering, it would be this kind of a parabola. Then it becomes constant when it is completely entered. And once it is leaving, it will be this kind of a parabola. Nah, so most people, right, they do like this. So just be careful with that. It's not that parabola. It's constant and then it drops like this. Isn't it? Look at this thing. Now it is like y is equal to a minus kx square parabola. How is this parabola? This is y is equal to minus x square plus constant. So it is an like this, no, pushed upward. It's a downward thing there. Now when you differentiate this, when you're entering inside, flux is increasing. So I'll oppose the external magnetic field. So current will go anti-clockwise. Anti-clockwise is positive. So it would be there and then it will drop to 0. And then it would start coming out. Then it would be negative. And then once it comes out again, this is how the graph will look. Clear with this? The currents will be, EMF will be linear. That way. If the flux is increasing, you need to oppose the external magnetic field. So then it will go anti-clockwise. Once you're coming out, flux is decreasing, I need to support. So it will be clockwise. Anti-clockwise is positive. All clear with this? Okay. Take a break. Come back by 9 o'clock. We'll start our speed test at 9 again. So make sure to revise the notes also later on. But that, what does the minus indicate, Yashil? The minus indicates